Hello and welcome back. In this video we're going to talk about functions and learning all about functions. This is a big topic, so this topic will consist of multiple videos. And you should already have looked at the enumeration video and the vector video. I'm going to build off those two programs. You might want to review the enumeration video and the vector video before we start this video. Okay, let's get started. So functions are really a building block for programs. You can think of functions as pillars or as part of foundation because your program will be built of many functions. And once you have written a function and, more importantly, tested that function and made sure that function is correct, you can reuse that function anywhere in your program, or you can also import it into other programs to use. Functions are very useful to programming. So let's talk about a real life scenario. Let's say your smartphone screen has been cracked and you need to bring your phone into a repair shop to have the screen replaced. So what are you going to do? You'll probably follow steps similar to what I've outlined here on the screen. You're going to bring the phone into the repair shop and tell the person behind the counter what your needs are. This is considered your output, a working phone. So you're going to give him some information and your phone, and you want as output a working phone. Now for the inputs, you're going to tell the person what's wrong with the phone, and you're going to hand him the phone. So these inputs are a broken phone, and you're going to tell him the screen is damaged. Since you handed the phone to the repair guy, and you do not necessarily care what he does to the phone except repair the phone and return a working phone to you, you could consider this a black box. He does some magic to the phone and he returns you a good phone. Functions function similarly, where you provide some inputs to the function and the function oftentimes will give you an output. So let's look at something in code right now. I have a couple examples, but I want to start with a program we can work on ourselves. So I'm going to launch Visual Studio. I'm going to create a new project, Win32 Console App, Visual C++, and let's just call this Get Hypotenuse, if that's how you spell it. Next, empty project, finish, go to Solution Explorer, right click on source files, add a new item, C++ file, and we will call this main. And we are going to return a 0. I want to stop right now and explain something. Int main, this is a function also. We have a function that's going to do a task and return 0 to, in this case, the operating system, meaning the program is done executing. The return value is this right here in front. So when I specify return 0, as long as I specify an integer here, I'm okay. If I were to specify a floating point number, that would not be correct because I'm returning an int. So let's return an int. The hypotenuse of a triangle many, many times. Well, we all know by Pythagorean theorem that c squared equals a squared plus b. You might consider writing this as such. Well, let's say we do that many, many times throughout the program. So you might want to create a function. But let's continue on here. Okay, let's run that and see if we're working. I'm going to press Control F5. Let's say it's a 3, 4, 5 triangle. And I have a problem here. I had a syntax error. I have fixed it. I had to include leg 2 on its separate line. So I have CN leg 1 and CN leg 2. Let's run this. Three, the hypotenuse of the triangle is 5. So that is effectively creating the hypotenuse. Now if we had to do this multiple times in the code, quite possibly we could make a mistake in this formula, or it would make the code less readable. So this is perfect for creating a function. Okay, so put all your functions above main. So it's going to return a double. Double get hypotenuse. Okay, nice thing about functions is a function performs some sort of action, so the function name should be a verb. In this case, get hypotenuse is perfect because it is telling the user or anyone reading this code that the function is getting the hypotenuse and it's going to return a double. So now we have our inputs. We have our inputs of the legs of the triangle. Now that we have the inputs, we will be able to determine what the hypotenuse is. So just like with our main program, we start off with curly braces, and this final curly brace on line 11 signifies the end of the function. So we want to return a value. So we could just state it this way: return and a semicolon. So let's go over this again. Our function is called getHypotenuse. Functions should always be verbs or an action. I have my inputs, the two legs of the triangle. The inputs must have a type. In this case, they are typed double. I'm going to return a value that is a double, and that value is the square root of leg 1 squared plus leg 2 squared. Pythagorean theorem. So now line 21 can change. I'm going to store the output of the function in hypot. And the function is called get hypotenuse. And I'm going to pass it. And you see, once I typed in the first parentheses, it tells me, the IDE tells me, that I need to pass a type of double leg 1 and a double leg 2. So I know I have to pass two parameters, and they're both of type double. Let's just call them leg 1 and leg 2. And let's add our semicolon. So this is now calling the function getHypotenuse. Let's step through this. We get our legs of the triangle. Once we hit line 21, we're going to call the function getHypotenuse and pass it two parameters. GetHypotenuse is up here. We know the two parameters have got to be doubles, and we know getHypotenuse returns double. As long as our return type is of type double and our two parameters that I'm passing are of type double, I'm okay. And I don't have any red squigglies. So if I was passing a string into here, strings are definitely not numbers, and I'm going to add red squigglies. So let's change this back to int or double, doesn't matter in this case. So the hypotenuse of the triangle is 13.8924 in this case. I want to touch on one thing before I leave this simple example. We have written a function to return the hypotenuse. If there is something wrong with this function, it can affect many things in our program if we call getHypotenuse multiple times. So you want to be sure that you test your functions and make sure your functions are working correctly before you say, okay, that function is good. One more thing. Notice I have leg 1 and leg 2 here, and I use leg 1 and leg 2 here. The leg 1 and leg 2 that are defined in my main program are not the same variables as the leg 1 and leg 2 in my function. They are distinct. Leg 1 and leg 2 in main live in main, meaning they are available to me anywhere in the main code, and this leg 1 and leg 2 are available only in getHypotenuse. It's called scoping, and you'll learn more about scoping later. But the scope of this leg 1 and leg 2 is the function only, meaning between the open curly and the closed curly. This concludes the initial video on functions.